Alright, we'll start. So before proceeding with the examples or numericals, I will just do a quick recap on vibration isolation and transmissibility. So we have already started with this topic. Alright, so we have identified four
Sir,
sources of, yes,
Can you reload the slide?
just a minute. How about now?
Mm, No, now also it is
Just hold
partial
on,
games.
just hold on few seconds. Still no?
No, sir, it is the slide is at the topmost left.
Oh, okay. Just a minute. How about now?
Yes, yes,
okay,
okay.
sir.
Okay, all right. So we have identified four sources of vibrations, and these vibrations are nothing but caused due to unbalanced forces. And to say isolate this vibration, we are using these isolators that can be made up of these various kinds of materials such as rubber, felt, cork, or metallic spring, which is the commonly used form of isolator. Okay, and we define the term force transmissibility, that is Ft by F0, and 1 minus one minus force transmissibility is the percentage isolation which is achieved. Okay, and we did the analysis and we solved for it, and we derived the equation for transmissibility ratio, that is Ft by F0, where Ft is the transmitted force, F0 is the impressed force, and this equation was uh, 1 plus 2 zeta r whole square divided by 1 minus r square whole square plus 2 zeta r whole square. Okay, now we also plotted the uh, curve for transmissibility ratio versus frequency ratio, and we discussed the various features of this curve and how this curve is behaving, and based on that behavior we demarked three zones. Alright, so these are the various properties of this curve. I am not going to go into detail, it is there in the notes, so you should be able to read from it, and it's also there in the previous lecture. Okay, so we divided this whole graph into three, demarcated into three zones. First zone is the spring control zone, middle one is the damping control, and the last one is the mass control zone. Okay, so this is where we were till the last lecture. Now we'll start with some examples. So starting with the first example. Okay, so I will just read the question before solving it. So a machine of mass 1000 kgs is acted upon by an external force of 3000 Newton at 1800 rpm. To reduce the effect of vibration, isolators having static deflection of 2 mm under the machine and weight and damping factor of 0.2 are used. Determine the amplitude of vibration of machine, force transmitted to the foundation, and third is the phase lag. Okay, there is the phase lag between the transmitted force and the excitation force or the impressed force. It is Ft and Fg. Okay, right, so one by one we'll start solving. All of you, please solve all these things carefully, because quiz are going to be based on at the end of each question there will be a quiz part. Okay,
Damping
so
factor means zeta or C.
you tell me. This is not like the first lecture, right? What do you mean by damping factor? Okay, so I will just summarize the data.
Zeta.
And so M is equal to 1000 kgs, F0 is equal to 3000 newtons, N is equal to 1800 rpm. That is the forcing frequency. So omega is twice pi n by 60 So that is equal to 188.50 radians per second. All right. Stiffness K is equal to F0 by del K is 1000, that is the static load 1000 into 9.81 divided by deflection, static deflection, that is 0.002 mm. Okay, so that is 4.905 into 10 raised to 6 Newton per meter. Right, so that is the stiffness. So omega n natural frequency is K by m, or that is equal to G by delta static. Both will give you the same answer. Okay, so I am going to use the G by delta static, 9.81 divided by 0.002. So that gives me 70.04 radians per second. Right? So R is the frequency ratio, that is equal to omega by omega n is 2.69. Right? So force transmitted, that is equal to, sorry, not force transmitted, force transmissibility. Force transmissibility is equal to TR, that is equal to FT by F0, that is equal to square root of 1 plus 2 zeta R whole square divided by 1 minus R square whole square plus 2 zeta R whole square. So F0 is 3000 and R is 2.69. So calculate Ft. Alright. So substitute the values in the equation. So Ft by F0 is equal to, right hand side becomes, after substitution, becomes something like this. Right. And zeta is given as 0.2. So Ft becomes 696.40 newtons. Alright. So now
Sir,
first,
sir,
yes,
sir. Can you show
yes.
the previous slide
No,
once
no,
again?
you should solve it. Just substitute the values and solve it. Don't copy from the slide. Right? So steady state amplitude is F0 by K divided by square root of 1 minus R square whole square plus 2 zeta R whole square. Alright, so now again you know all the values. F0 is, this is 3000 and K is, you have calculated this K value, and that is 4.905 4.905 into 10 raised to 6 Newton per meter. All right, and substitute all the values in this equation and find out x. And similarly, phase lag is equal to phi minus alpha. So this is the second part which you have to calculate it, and that is equal to tan inverse of 2 zeta r upon 1 minus r square minus tan inverse of 2 zeta r. Alright. So you know all these values in this equation, substitute them and find out phi minus alpha. Okay. So now open up your quiz. Now you have to enter the value of x and this phase lag. Alright. Now when you substitute the answer for phase lag, there is an important hint when you write the answer. See, this value has to be always positive value. Okay, why? Because phase lag is what? The phase angle between phase angle between force transmitted and impressed force. Impressed force, it is F0. Alright. So this value cannot be negative. What does the negative value means? That the impressed force lags transmitted force. Okay. Okay. So that means what? The impressed force is coming after the transmitted force. That doesn't make any sense. Alright. The impressed force should always come before the transmitted force. So the phase lag between the impressed force and the transmitted force should always be a positive value. Okay, negative value means this comes after this, means which in practical sense is not possible. All right. So this value should be a positive value. Okay. So this is the hint which has been given to you. So calculate both the values and substitute your answer in this quiz in this format. Now when you are substituting the values for today's quiz, all the answers are to be rounded off. Final answers in the blank are to be rounded off to the nearest whole number. Alright. So that is star 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 dot 0.9. Then this becomes star star star. Let's make this 0. 345.9. Then this has to be rounded off to 346. If something is 345.1, it is rounded off to 345. Okay. So if the value after the decimal is less than is greater than 0.5, take it to the higher value. If it is less than 0.5, take it to the lower value. Okay. So all these values are to be rounded off in this format. Okay. So open up the quiz and I will give you 2 minutes. So it is 9:23. Submitted till 9:25. You have to submit the answer at the end of the what do you say, at the end of the lecture. All right. Time is up. Next question. All right, so I will just read the next question. A 100 kg turbine operates at 2000 rpm. What percentage of isolation is achieved if the turbine is mounted on a 4 identical springs in parallel with each other? Okay, each of stiffness 3 into 10 raised to 5 Newton per meter. So we'll see this question. So let me just summarize the data. So forcing frequency is 2000 rpm, mass is 100 kgs, omega is twice by n by 60, so that is 209.44 radians per second. Omega n is equal to k equivalent divided by m. Since there are 4 springs, k equivalent is going to be 4k. Alright, so that is equal to 4 into 3 into 10 raised to 5, so that is equal to 12 into 10 raised to 5 Newton per meter. Alright, so omega n is 12 into 10 raised to 5 divided by mass 100, and that comes out to be 109.54 radians per second. Alright, this is just the summary of the calculation. Now, see, in the data, nothing is mentioned. Okay, since nothing is mentioned, take zeta is equal to 0. So always, if the value of damping ratio is not given, take it as 0 and solve the example. Okay, so R is equal to omega by omega n. So that is equal to 209.44 divided by 109.54, and this counts out to be 1.911. Alright. So now transmissibility ratio TR is equal to square root of 1 plus 2 zeta R whole square divided by square root of 1 minus R square whole square plus 2 zeta R whole square. Okay. So now here substitute zeta is equal to 0. Okay, substitute zeta is equal to 0, and so TR becomes 1 upon R square minus 1. Okay, so make sure you write it in this format. Don't write it 1 minus R square, because this is the root. So root can be plus or minus negative. So we are going to take plus sign when R is greater than 1. Okay, so here R is, find the value of R is here 1.911. Okay, so find the value of TR. Okay, and you are required to find out percentage isolation. So percentage isolation is 100 into 1 minus transmissibility ratio. Okay, and open up your second quiz question, open up your quiz question and answer the this third quiz question, that is isolation. Again, round it off, round off your answer, okay, to nearest whole number. For today's quiz, do not write any answer in decimal unless I tell you. So all the answers should be without decimal. For calculation, you can use the actual value, but while writing the answer, just for for making the evaluation uniform, you have to write the answer by rounding it off to the nearest whole number. Again, I will give you 2 minutes. So it is 9:29. 9:29, 9 till 9:31. Any questions? Please ask. All right, done. Nobody is saying anything, so I can assume that you can go to the next question. All right, so let's read the next question. All right. An air compressor of 450 kgs operates at a constant speed of 1750 rpm. Rotating parts are well balanced. The reciprocating part is 10 kgs and crank radius is 100 rpm, 100 mm. Okay. The mounting induces a viscous damping of damping factor 0.15. Specify the spring stiffness for the mounting such that only 20% of the unbalanced force is transmitted to the foundation. So only 20% of the unbalanced force should be transmitted to the foundation. Find out the amplitude of the transmitted force. All right. So let's try to solve this example. Understanding the data is first important. So one by one we'll first chart out the data. So mass is equal to 450 kgs. RPM n is equal to 750 RPM. Omega is equal to 183.26 radians per second. M0 is equal to 10 kgs. E is equal to 0.1 meter. That is the crank radius. Zeta is equal to 0.15. Zeta is equal to 0.15, not meters. Now, from the data given in the question, see, you have to read the data carefully. It says that rotating parts are all well balanced. Okay, so they are saying that there is no rotating unbalance. Okay, only unbalanced force will be due to the reciprocating part, because it doesn't say that the reciprocating force is unbalanced. Okay, so you have to solve the example. So this is a case for reciprocating unbalance. All right. So this is the data, and you are required to calculate the stiffness. Second, the transmissibility ratio. No, sorry, transmissibility ratio is given as 0.2. That should be the transmissibility ratio. And third, uh, not third, transmissibility ratio is actually given. So TR is 0.2. So you have to find stiffness, and second thing you have to calculate is the amplitude of the transmitted force. So that is the FER. These two things you have to calculate. Okay. So let's start by calculation of stiffness. So for calculation of stiffness, we need to first calculate the frequency ratio. So for that we'll use the transmissibility ratio equation. So that is equal to square root of 1 plus 2 zeta r whole square divided by square root of 1 minus r square whole square plus 2 zeta r whole square. All right. Okay. So this is the transmission. So substitute this is equal to 0.2, and you know the value of zeta. Okay. And substitute and find out value of r square. So value of r. So this will be you will get a quadratic equation of r square. All right. So find out the value of r square. Right. So I will just write down the consistency. So this is 0.2 into square root of 1 plus 2 into zeta 0.15 into r whole square divided by square root of 1 minus r square whole square plus 2 into 1.15 into r whole square plus it r whole square. So square it, take the square of this equation. So and you will get a quadratic equation that is something like this: a r raised to 4 plus b r square plus c is equal to 0. Alright. So find the roots of this quadratic equation r square. So you'll get two roots. Choose the correct value of r, then take the square root of that. So r is equal to, you will get something after you take the root, and r is nothing but omega by omega n. Omega is the forcing frequency, and that is equal to, that is 1750 rpm into radians per second. This is 183.26 radians per second. Omega n is square root of k by m. M in our case is 450 kgs. Right. So solve this equation and get the value of k. So this is the first part of the question. Now second part of the question, you have to find out the amplitude of transmitted force. Alright. So FTR by F0, this is given as 0.2. So you have to find out FTR, and F0 is M0 omega square into E. Okay. So this equation will give you a value of force transmitted. So evaluate both these values and answer the next quiz question number 4 and 5. Be careful with the units. The units of stiffness is in terms of mega Newton per meter. So whatever answer you get, you have to convert it into mega Newton per meter and substitute. For force transmitted, it is Newton. Again, answer is to be rounded off. Okay. Don't write any value after the decimal, just round off to the whole number. Both the answers. So for this, I will give you 5 minutes because there are more calculations involved. So time is 9:39. So you have till 9:44. So any questions, please ask. Have you downloaded the MATLAB software? Next week I intend to do the MATLAB programming practical. Alright, time is up. Let's go to the next question. Any questions? Can I continue?
Sir, we aren't done. Can you give us 2 minutes?
Okay.
Can you switch to questions? Just once.
Huh. Okay, one more minute. After that, we'll going to continue. 9:44 was intended time. So 2 more minutes. That is 9:46. All right. So time is. Let's continue with the lecture. Okay, it's already 9 more minutes plus 2 minutes. Extra 2 minutes are already given. All right. Next. Can I continue? Is everybody done? Right. So since there are no objections, I am assuming that everybody is done. So I will continue. Next, the static deflection of an electric motor of mass 500 kg supported by a system of 4 parallel spring and no damping is found to be 60 mm. Okay, so here if the rotating unbalance is 0.2 kg, if the rotating unbalance is 0.2 kg meter, determine the amplitude of vibration at 2000 rpm. Okay, force trans and determine the amplitude of vibration at 2000 rpm and force transmitted to the ground. Right. So these two things you have to find out. So let's start. So this is again. So this is the example of rotating unbalance. So we have to write the equation for rotating unbalance, that is steady state amplitude for rotating unbalance, and that we have derived this. So this comes out to be x divided by m0 e by m is equal to r square divided by square root of 1 minus r square whole square plus 2 zeta r whole square. Alright. Now here it is given that the system is undamped. There is no damping. So zeta is 0. Alright. Now omega n is equal to g by del. So that is square root of 9.81 divided by 60 mm. So that is 0.06. So that is equal to 12.79 radians per second. Okay. Forcing frequency omega is 2000 rpm. So convert it into radians per second. So it is twice pi into 2000 divided by 60. So frequency ratio R is equal to omega by omega n, and this comes out to be 16.38. Right. All right. Okay. Now for rotating imbalance, for rotating imbalance, our equation becomes x divided by m0e divided by m, and since zeta is equal to 0, right hand side reduces to the form r square divided by r square minus 1. Again I have written this in this format, not 1 minus r square but r square minus 1, because r is greater than 1. Okay, and that is in our case r is how much? 16.38. R is equal to 16.8. So since it is greater than 1, write the equation in this format. So substitute the value of all these values. So now in the question what is given, if the rotating imbalance is 0.2 kg meters. So now here you have to please be careful and read the units. So here it is 0.2 kg meters. So here directly m0 into e is given. Alright. So separately m0 and e is not given. Directly the value of m0 into e is given. So you have to directly substitute that value in our equation. So m0 e is 0.2, m is 500, r you already know, so calculate. R is this 16.38, so calculate x. Alright, so that is the first part of the question. Second part is you have to calculate force transmitted, Ft. Okay, and Ft by F0, that is the transmissibility ratio, is given as 1 plus 2 zeta r whole square divided by 1 minus r square whole square plus 2 zeta r whole square. Alright. So here it is again given zeta is 0. So this part goes, and so this reduces to 1 upon r square minus 1. Again it is not 1 minus r square, it will be r square minus 1. Okay. So you know value of r. Okay, r is 16.38, and f0 will be m0 e into omega square. Alright, so that is the rotating unbalanced force. Alright, where omega is going to be the forcing frequency, which is already given in the data. Alright, so substitute the value of f0 in this equation and substitute all the values in the equation for steady state amplitude, that is this x. This is the steady state amplitude. All right, and find your answers.
Can you not hear what I'm saying?
Yes. Hello.
Hello, sir. Could you go back a screen?
Why?
So just so that we could see that.
Which part? See, x is equal to m0 e by m is equal to r square upon r square minus 1. This is one equation. All right, and ft by f0 is 1 upon r square minus 1. f0 is m0 e omega square. Now what do you need in this?
Yeah, sir. Okay.
Write your answers again by rounding off to the whole number. So here, see, the answer is written in this format. It is your answer, whatever it is, answer into 10 raised to minus 4 meters. So it should be in the same format. Okay. The answer is already multiplied by 10 raised to minus 4 meters. So you adjust your answer accordingly and write the answer, write both the answers to nearest possible whole number. Whole number. Any questions? So time is 9:55. So I will give you 3 minutes more. Already time has been given. So 9:55. You have till 9:58. All right, moving on to the next question. Can I go to the next question? I assume nobody's saying anything, so everybody's done with this question. All right, so let's read the next question. A single cylinder engine of total mass 180 kgs is to be mounted on an elastic support which permits vibratory movement in the vertical direction only. The piston of the engine has a mass of 3 kgs and has a vertical reciprocating motion which may be assumed to be SHM. Okay, so it is a simple harmonic motion with stroke of 150 mm. It is desired that the maximum transmitted force through the elastic support to the foundation shall be 500 newtons. So the force transmitted cannot be more than 500 newton. It has to be less than or equal to 500 newton. Okay. When engine speed is 800 rpm and less than this at higher engine speeds, when the engine speed is 800 rpm and less than this at higher rpm. Okay, find the necessary stiffness of the elastic support. And amplitude of vibration of the engine at 8000 rpm. All right, so this is the question. So we'll start solving the question. So let me summarize the data. M is equal to 180 kgs, M0 is equal to 3 kgs, R is equal to 0.075 meters, so Ft is equal to 500 newtons at N is equal to 800 rpm. Therefore, forcing frequency omega in radians per second is 83.78 radians per second, and Ft should be less than 500 newton. That is what the statement means at N greater than 800 rpm. All right, so that is what the statement of the question means. You have to find stiffness K and the steady state amplitude X and X. All right. So omega is 83.78 radians per second. So F0 is equal to M0 E into omega square. Now M0 is 3, E is half of the stroke. Stroke is 150, so it is half of this. Okay, half of into 1 upon 1000, so converted into meter. So it is given that stroke is 150. So for calculation of, I should write it as E actually, not R. So it's E is 0.075. Okay, so E is 0.075 and omega is this value, and this comes out to be 1579.3 newtons. Okay, and Ft is 500 newtons. All right, so Ft by F0 is equal to 0.317. Right. Now we'll do the graph of this. Any questions so far? Can I go to the next slide? All right, this is just the summary of the calculations. Okay, now we have to draw the graph. Okay, so I constructed this graph of transmissibility ratio on y-axis and frequency ratio on x-axis. Okay, so now Ft is equal to 500. So when the transmissibility ratio is 0.317. Okay, now when this goes beyond, and RPM, corresponding RPM is 800 RPM. All right. So what is the desired condition? If you go beyond 800 RPM, then the transmissibility ratio should be below 0.317. So F force transmitted, Ft will be less than 500 Newton. All right. So this is the design. These are the design conditions. Any questions regarding this? Can I go to the next slide? All right. And since again nothing is specified, so I am solving for the condition when zeta is 0. All right. So first let's calculate the frequency ratio, that is this RA. All right. I am calculating the frequency ratio RA. So FT by F0 is equal to 1 upon RA square minus 1, and this is equal to 0.317. All right. So RA is 2.04. Right. So that is omega by omega n is equal to 2.04, and omega is 83.78, and omega n is k by 180. So this is equal to 2.04. So calculate k. All right. So that is one part of the question. Second part of the question, x divided by m0e by m is equal to, the second part, is equal to RA square upon RA square minus 1. Okay, so this is the equation. This is the equation for the steady state amplitude in our case. Okay, so that is for reciprocating imbalance. Okay. All right, so this is for equation for reciprocating imbalance. All right, so m0 is 3 kgs, e is 0.075, and total mass is 180 kgs. So and RA is 2.04. Right. So all the values are calculated. Sorry, all the values are known. Find out the value of x. All right, and so substitute the value of k in this equation. Any questions? I will just write the equations again on this page for your reference. So here you have to use the equation of R, that is omega by omega n, and omega you know, forcing frequency, omega n is square root of k by m, you know value of m, this is known, given. Okay, this is also given in the data. R is nothing but RA that you have calculated, so you have to find out k in this thing. All right, and for steady state amplitude it is x divided by m0e divided by m is equal to RA square upon RA square minus 1. All right, so here you have to find out x. Now when you are writing the answer, k should be in kilonewton per meter and steady state amplitude is in millimeters. Any questions? Okay, you can open up the quiz and
Sir, both the whole numbers, no?
whole numbers, everything whole numbers. Whole numbers, yes, whole numbers. So if this is, see this value, if it is getting say 10.98, okay, so you have to round it off to 11. Don't make it 10, it should be rounded off to 11. So like that, if it is greater or 10.6, again you have to round it off to 11. So like that you have to do. You have 2 minutes to complete this. So it is okay. It is to the end of the lecture. So I'll just take the attendance.
Sir, one more question is there.
I will delete that question. Alright, so question number 10. I have deleted that. Just refresh your page and now you should see only 9 questions. So substitute the values for 9 questions and you can submit the answer. So before downloading that MATLAB, it takes a lot of time, and no, make sure you download it and install it and keep it ready, because if you run it for the various times, then all those binaries need to gets compiled for the first time, so it takes a little bit of time. So I want you to download the MATLAB, install it, and keep it ready. So next, what do you say? Next Tuesday, we have the practical for B1 batch. So in that practical, I will be doing the MATLAB part first, and then we'll do the other practicals, because you will need that for the assignment also. Now in the assignment, uh, in part of that assignment, you need to do that part either by using Excel or by using MATLAB. MATLAB part I will be teaching in the next week, uh, when you have your setup ready. If you don't have, if you are not able to, like if you don't have any access to PC or internet or anything like that, then you have to treat that practical as just a demo practical. I want you to do the programming along with me simultaneously. So I will be writing the program and explaining it. So I want you to write the program simultaneously, and
So, what is the size of the MATLAB software?
it is a big software. It will be more than, I just let me check. So it is not compulsory that everybody should have it, but if you have it, you will enjoy it. Alright, time is up. All of you submit your answers. I am closing the quiz. Size is, it is approximately 2 GBs, 2.25 GB, 2.25 GB. That is just the exe file. After installation, it will be much bigger.
Okay, sir. Okay.
Alright, I am closing the quiz. See, once the quiz is closed, no, I am not going to allow any excuses. Huh? So submit it. Okay, the quiz is closed.
Can you post the answers?
Yes, yes, yes. All right, scores are posted, and have a look at it. So if there is anything else, that's all for today. Thank you.